Hello students, welcome back to Playing Trigonometry. This is Dr. Olson. Today's lesson is called Angles Formed Inside, Outside, and on a Circle. We'll be looking at some theorems again on circles from Unit 25. Our objectives for today are going to be, first of all, to apply chord, tangent, and secant theorems in computing arcs and angles formed inside, outside, and on a circle. And then second, we'll be solving some applied problems using those theorems discussed in this lesson. However, we won't do those applied problems until you come back to class. Let's review first of all how we describe arcs. Recall that an arc can be described in two different ways. First, it can be described by the length of the curved line that forms the arc. So, if we look at the arc PQ in the drawing below, the one that is shaded now in gold, if the length of that curved line was 7.64 centimeters, then we could write arc PQ is equal to 7.64 centimeters. On the other hand, we can also describe the arc by the measure of the central angle that intercepts that arc. Your book says instead of intercepting, it says subtends the arc. But we're talking about this angle, and suppose that it measured 82.5 degrees, then what we could say is that arc PQ is equal to 82.5 degrees. So two ways of describing the same arc, one by the length of the curved line and one by the angle. Let's look at our first theorem for today. It says an angle formed by two chords that intersect within a circle is measured by 1/2 the sum of its intercepted arcs. Let's look at the diagram below and see how this applies to this theorem. We do have two chords drawn in the circle, and they intersect at that point P. I want you to notice that that point P is not at the center of the circle. Therefore, the angle APB and the angle CPD, those are not central angles. They are vertical angles, so they are equal to each other, but they are not central angles. Therefore, if we say that the arc AB is 38 degrees, we're not talking about this angle APB being 38 degrees. We're talking about the central angle that would intercept that same arc. So in other words, if this was the center of the circle, then the angle that would be formed that intercepts that arc AB from the center of the circle, that would be 38 degrees. Likewise, if this arc CD is 64.2 degrees, we're not saying that the angle CPD is 64.2 degrees. We're saying if we could draw out the central angle that intercepts that arc, then that angle would be 64.2 degrees. Our job on this slide is to actually compute the measure of angle CPD and the measure of angle APB in the circle that's shown on the left. And we're going to apply this theorem that says angle CPD is going to be equal to 1/2 the sum of the intercepted arcs. Well, the intercepted arcs are the arc CD and the arc AB. So since the measure of those arcs are already given, we can substitute that in our formula. The arc CD was 64.2 degrees. The arc AB was 38 degrees. So we simply add 64.2 to 38, and we get 102.2. So we're going to take half of 100.2 degrees, and half of 102.2 degrees is 51.1 degrees. So angle CPD will be 51.1 degrees. But remember that angle CPD and angle APB are vertical angles, so they must be equal. So we can say that angle APB is also equal to 51.1 0.1 degrees. Let's look at our second theorem now. It says an inscribed angle is equal to 1/2 the measure of its intercepted arc. And let's look at the diagram of the circle on the left-hand side. You'll see that we have an angle ADC, and this angle has its vertex actually on the circle. That makes it an inscribed angle. You'll see that it intercepts this arc from A to C, which is given as an 80-degree arc. When it's given as an 80-degree arc, that means the central angle that intercepts that same arc actually measures 80 degrees. You can see that the angle ADC is not going to be nearly as big as that 80-degree angle. In fact, it's going to be exactly half of it. So applying this theorem, we can say that angle ADC is equal to 1/2 of 80 degrees, which is 40 degrees. Pretty easy. What you're going to find is that all these theorems we're going to be talking about today have one thing in common. They are half of something. Your job is going to be to remember what they are half of. Let's look at theorem number 3. An angle formed by a tangent and a chord at the tangent point is measured by 1/2 its intercepted arc. So this is basically just like theorem number 2, but instead of it being an inscribed angle, it's an angle that's formed by a tangent, such as this tangent line AC, and a chord, such as this chord AD. So we're talking about this angle, angle CAD. Now, it says that this angle is going to be measured by 1/2 its intercepted arc. Well, the intercepted arc goes from point A around the circle to point D. So this is the arc we're talking about, and it's given as 154 degrees in the diagram. So the measure of angle DAC is going to be half the measure of arc AD, and arc AD in the drawing is given as 154 degrees, and half of 154 is 77. So we can say that angle DAC is equal to 77 degrees. Let's look at theorem number 4. Theorem number 4 actually has 3 parts. It says an angle that is formed outside a circle by 2 secants, 2 tangents, or a secant and a tangent is equal to 1/2 the difference of the intercepted arcs. So I want to look at each of these 3 situations separately. Okay, taking the first part where it says an angle that's formed outside a circle by 2 secants. So look at the circle on the left-hand side. We have a secant that's drawn from point P outside the circle through points C and D on the circle, and then we have a secant that's drawn from that same point P through points A and B on the circle. The angle between those 2 secants, in other words this angle BPC, that is going to be measured by half the difference of the intercepted arcs. So that angle P is going to be half of the difference of 80 degrees and 20 degrees, because the 2 intercepted arcs are these arcs BC and the arc AD, and they are given in the drawing as being 20 degrees and 80 degrees. Well, 80 degrees minus 20 degrees is 60 degrees, so that's going to be half of 60, which would be 30. So we can say that this angle, angle P, is 30 degrees. Let's look at the second part of this theorem. The second part says that an angle that's formed outside a circle by 2 tangents. Okay, so let's look at the middle drawing this time. In the middle drawing, we have a tangent line that's drawn from point P outside the circle through point B on the circle. We have another tangent line that's drawn from that same point P through point C on the circle. What we're looking to do is compute this outside angle, the angle P. Of according to the theorem, it is 1/2 the difference of the intercepted arcs. Well, the intercepted arcs are the arc BC going around this way, which is measured as 105 degrees, and the major arc BDC, which goes around the circle this way, and we can find the measure of it simply by taking 105 and subtracting it from 360. 360 minus 105 is going to be 255. So the measure of arc BDC is 255 degrees. So if we want to get the measure of angle P, we just need to take half the difference of those two arcs. So of course start with the larger arc, which is 255, subtract 105 from it. 255 minus 105 is 150, and half of 150 is 75. So the measure of angle P would be 75 degrees. Let's look at the last situation. This time it says an angle formed between a secant and a tangent is equal to 1/2 the difference of the intercepted arcs. So in the drawing on the right hand side, what you'll see is we have a secant that's drawn from point P outside the circle through points A and E on the circle, and then we have a tangent line that's drawn from point P through point D on the circle. We're going to be looking for this outside angle, angle P, and it's measured by half the difference of the two intercepted arcs. Well, one of the intercepted arcs goes from A to D, and it's shown as 58 degrees. The other intercepted arc is between points E and D, and it's shown as 178 degrees. So angle P in this situation is going to be 1/2 the difference of 178 and 58. 178 minus 58 is 120. Half of 120 is 60. So the arc P would be 60 degrees in this case. This concludes the last theorem of this lesson. I hope what you've seen in all these theorems is that the angles that we're looking at are either on the circle, they are inside the circle, or they are outside the circle. And they're always measured by half of something. We'll review in class these theorems, but just for your own benefit as you're working through practice problems, remember that if the angle is inside the circle, then it's half the sum of the intercepted arcs. If the angle is on the circle, it's just half of that arc. And if the angle is outside the circle, as in this last example, it's half the difference of the arcs. Make sure you print this handout and bring it back to class with you the next time we meet, and we will do the applied problems that follow in this lesson. And this is Dr. Olson, and I'm signing off. I'll see you in class.